Okay, moving on to question 16, we have been given a triangular prism. We've got that the base of ABCD is a rectangle. We've been told that AD is 25, DC is 22. So we can say this is 22, this is 25. G is a point such that between A and D, there's the ratio 1 to 5. So this will be 1/6 at the length. This is 5/6 of the length. And we need to find the size of the angle between EG and the base of the prism. So just to kind of visualize what we're looking at, if I draw a line here, that is EG. If I draw a dotted line for what is the base, we need to find this angle theta, so the angle between EG and the base. Okay, so starting off with, we've got quite a few different triangles we can deal with. Right, we know the base. If we look at the triangle we're going to address first, got that there. So this is 22. Let's see. We don't know the height, and we don't know x, we don't know y, we don't know that theta, so we don't have a lot of information to be working with. Okay, so we can start off by kind of trying to fill in the gaps with some of the other triangles. So, and if we say that is M, this is that triangle. So, let's see. We can start by trying to work with perhaps, let me do this in another color. If I draw a line here, there's that line there. That is a right angle triangle. Now we have slightly more information because we know this is a right angle. The length EM is in common with the triangle we're trying to fill in the gaps for. So if we draw that out, this is 1/6 multiplied by 25. That length we don't know. The height is also we don't know. And we don't have a lot of information, but we can find out what that's BME. EB is the same as FC, which we can find out. So, okay, so we've also been given an angle here, 43. This is 90, so we can figure out this angle as 47 degrees. Now then, because we've got 3 angles and one side, we can use the sine rule to figure out what FC is. So, sine of 47 over 22 is equal to sine of 43 over FC. So then FC is equal to 22 sine 43 divided by sine 47, which is equal to 20.5. If I'm correct. I'm going to double check that quickly. Yeah, 20.5 is our length here. And to find out let's see, 20.5, we can find out FD, but I don't think we necessarily need that. So, ED is equal to FC, or EB even, that should be a B. So then X is 20.5. Okay. And then we can use Pythagoras to figure out y. So y is equal to the square root of 20.5 squared plus 25/6 squared. And that gives us, let's see, 20.9. So that's 20.9 there. And we need the angle. Okay, so we figured out that triangle. EM is then 20.9. So now we've got two sides. The angle is theta. We've got the opposite. We've got the adjacent. So then we can use tan. So tan inverse of 20.9 divided by 22 is equal to 43.5, which is precisely the angle we've been looking for. It is a bit long-winded, a bit messy, but it's easy. Best way to approach it is to try and fill in the gaps wherever you can, so you can fill in missing information, which will make solving the problem much easier. Okay, question 17, we have got simultaneous equations that we need to solve. So we need to solve to find x and y. So if I go back to black, I can rewrite this first equation as x is equal to 7 minus 2y and substitute that in here. So expanding and simplifying, so okay. Right. So 4y squared minus 6y squared is minus 2y squared plus y squared. That's minus y squared minus 7y plus 24 is equal to 0. So I've just simplified the whole thing. And this is not so easy to solve. So if we put it into the quadratic formula, y is equal to minus 7 plus or minus square root of 7 squared minus 4, a is minus 1, c is 24, divided by 2 bracket 1. Okay, and y will be equal to 2.52 or minus 9.52. And if we substitute these back into our first equation where x is equal to 7 minus 2y, we can plug in y is 2.52 and y is minus 9.52. So then we will get x is equal to 1.96 or 26.04. Okay. And question 18. So we've been given that at the start of the year t is CT, and we've been told that at the start of year 1 it's 752. So CT plus 1 is equal to 1.055 CT. If we want C2, C1, so we substitute in 752, and this will give us 793.36, which we will round up to 794. C3 is 1.055, C2, which is 1.055 multiplied by 794, which is 838 to the nearest whole number. C4 is 1.055 multiplied by 838, which is 884 to the nearest whole number. Which is what we needed. We needed to find the number of cats at the start of year 4. So, for part B, we need to... Okay. Samantha uses the same formula to calculate the number of cats in the same town at the start of year 6, and her answer is 982.83. To identify what is wrong with her answer, you can't have 0.83 of a cat, so you need the number of cats to be a whole number, not a decimal. Okay.